Hello, today's video is going to focus on finding linear equations. The difference between this and earlier editions of this video is that we're going to be working with context. The point I would like to make in this lesson is that the only difference between the work I'm doing now and the work we did last week, where we're finding the equation of a line, the only difference is I have a context which will help me determine if my answers are reasonable, if they make sense. So here's what we have. We've got a club who's hosting a fundraiser, and the profit, of course, depends on how many people attend the fundraiser. And here's some things we know. If 100 people attend, we get $2,500 profit, and if 80 people attend, we only get $1,500 profit. So, assuming a constant rate of profit, so when you see the phrase constant rate of profit, that sort of implies linear functions, express profit as a function of attendance. So all I know is I'm looking for a linear function where attendance is the independent variable, and profit depends on how many people attend. A follow-up question is determine the profits if 130 people attend. So, what I need to do here is to be a little bit more organized than just sort of randomly trying to fit variables together. So I need to first define my variables. What are the variables in this setup? And because they were told us at the beginning that profit depends on the number of people attending, we know that A could represent the attendees, and that would be the X variable, independent. Profit represents the amount of money that's made, and that depends on the number of attendees. So P is a function of A. Then I have to read the paragraph and extract data from it. In other words, I should be able to find 2 points on this linear function. The first being 80, 1,500, and the second being 100, 2,500. So here represents the X, or number of attendees, and here represents the profits. So make sure they have the X's and the Y's lined up accordingly. The next job here is to actually put these data onto a graph so that I could actually see what's going on overall. The important thing here is to recognize that graphing skills haven't changed. The only difference is we have to go back to choosing appropriate scales. The X's I have to go at least up to 130, so I exceed that. The Y's have to go up as high as 2,500, and I didn't find out until afterwards. We're going to have a pretty low y-intercept here as well because of the nature of this function. So the observations that I made here is apparently we're going to have a negative profit if nobody attends this fundraiser. And apparently I'm going to need at least 50 people to attend to break even. Any more people than 50 means real profit for this key club. So in order to find the equation of the line, I'm given 2 points. I need to know the slope of the line, so that's what I'm going to do first. First, by observations, I recognize an increase of $1,000 profit for 20 people, so I could pretty much guess it's going to be $50 per person. But to make sure that I'm using communication and applying all the skills that we learned in previous chapters, I show the rate of change as change in Y over change in X, and then I find the 2,500 to 1,500 gives a $1,000 difference over 20 different people, which equates to $50 a person. So again, that's consistent with what I see here. Every person gives me $50, every 10 people is going to give me $500. So we can go over 10, up $500, and we can go over 10 more and up $500. So just count by tens, and each time we'll get an extra $100. Or we can count by 20s and get $1,000 more. Either way. To get the equation of the line, all I have to do is find any point on the line and walk it back to the origin. So here I can see that from this point it's drifted away from home by $1,500 and by 80 people. So I put the minus 1,500 here and the less 80 people here according to the variables, and then all I have to do is solve for y. I put this back into function form so that the variables all match what I already defined in the beginning, and I check quickly to verify that the other point that I didn't use, 100, 2,500, that's also a solution to my equation, to make sure that all my math is done correctly up in here. So, oops, that went a little fast. Re-examining the graph again here, we can see the final question that we have to ask is what happens when x equals 130? That is, what if 130 people attend? So all we have to do is follow the graph up and over, and we could see that about 4,000 is probably going to be the profit. So that's my guess. I put that into my equation, and I find 4,000 indeed is the correct value. So they would make $4,000 in profits if they could just get 130 attendees. Now the other two things we're doing here, we're not explicitly asked questions, but they are the kinds of questions that could be asked. They refer to the interesting points, the intercepts in this case. First intercept 50-0 tells me that they need at least 50 attendees in order to turn a profit. If they get less than 50 people, they're going to lose money on their fundraiser, which means they'll probably get fired from their nonprofit. The other thing is they need to cover $2,500 in costs. So the y-intercept is actually telling me how much it costs to set up the fundraiser. What I did here, by the way, is my graph said 50 attendees, but I can verify that with my equation by saying 0 profits, how many attendees, and the answer is 50. Similarly, I can say if 0 people showed up, what's my profit going to be? And it's going to be negative 2,500. So that infers my cost of 2,500 to run this thing. Now the last thing that we should mention is all of this work seems really sound in itself, checking, but it's worthwhile to follow up with technology in some of these situations. You see, what I did is I started by plotting the point 80, 1500, and 100, 2500, and then I reset my scale, my new window from the wrench up in here. And so those are the 2 points that I was given. This is the equation that I found, and when I type that equation into Desmos, I find that it actually does generate the exact same line that I saw in my work. So I feel really good about this. Thanks for watching. Have yourselves a great day.